Hey Max, this is Mr. DeVore, and just want to make this quick video for you to answer some of the questions that you had on your study guide. So I'm only going to do the ones you had, but I did notice that there was a kind of a pattern in some of them. So this number 4 will be a good place to start. Okay, so find the length, the arc length, right? That indicates arc length AB. So we're just talking about this length here, okay? And remember, anytime we have an arc length, let me just draw it over here too, right? AB, okay? That's just part of the whole circumference, okay? So we have a nice formula for the circumference of a circle, and what we do need to find that circumference of the circle is we need the radius, and we do have that here. So the circumference of this entire circle is 2 pi r. In this case, our r is 2. So our circumference is 4 pi. So that's the distance all the way around. But we don't want all the way around. We just want from A to B. So it's a fraction of this whole thing. And so that fraction is, well, the clue here is this 50. Okay. So that 50 degrees is this fraction of, instead of going all the way around, from start to finish from this line here of 360, okay, we're going from here to there, right? So this 50 degrees here. So what this is a fraction of that, and that fraction is 50 degrees out of 360 degrees. So if we go ahead and do that, the fraction is 5/36 of the circumference. So let's now put it all together. The arc length of AB is equal to 5/36 times 4 pi. Then we'll just do just a little algebra. Let's clean that up. 5 pi over 9, and that's our arc length. Remember, that's the length, okay? Okay, so now it says find the circumference. So again, we're going to be using this idea here, circumference, given an arc length of 25. So now we know the arc length. Now notice we don't have anything here about radius, but that's okay because we do have the fraction of the entire circumference here. That fraction of the circumference is 25. And so that's a fractional. What's the fraction? Well, it's 120 over 130. So it's saying that this 25 is 1/3 of the whole circle, right? That 1/3, where did I get that? From that, okay? So it's 1/3 of the circumference. So let me draw a better drawing because this isn't a very good drawing of the, here, let's try to eyeball this a little bit better. So if this is 120 and this is 120 and this is 120, see that takes up the whole 360. And we're saying if this is 25, so if we can see that over here, 25, well, that means this is also 25. This is also 25. So our full circumference will be 75. Okay, let's. I think we're going to skip past these. We are going to come back to them, but they're kind of a different topic. Okay. All right, and going to this. Now, the only one that you asked for is this, but really, once you know this, you can find these. So ultimately, let's look at the radius of this. So it's in the area of the entire circle is 295.52. That's the circle R, okay? So we're saying the area, right, we're gonna use this formula, is pi r squared, the area. So we know the area, 295.52 equals pi. Remember, pi is just a number, so don't make it a big deal, it's just a number. Okay, in fact, here's what I'm gonna do, just so that you know it's a number, right? We'll abbreviate it 3.14, okay? So at this point here, it's just an algebraic equation solving for r. So how would we isolate r? Well, we would divide by pi, or in this case, we'll just go ahead and put 3.14, right? That gives me r squared. Still got to get r alone, so that's, again, just a little algebra. Let me get that. And this is something you could just go ahead and plug into your calculator. Square root of 295.52 over 3.14. Okay, so I'll let you put your calculator skills to use on that. Okay, that's where you get that. It looks like to be about 10 or so. Okay, all right. Over here. So now we're talking about area of this sector. Okay, so now we're going to be coming over here. So find the area of this shaded region. So this shaded region right here. So what it is telling me is that I have a radius of 5. So if I was asking you the area of this whole circle, well, that's easy. Area is pi r squared, and that radius is 5 squared. So our area is 25 pi. Okay, so that's of the whole thing. Okay, but I don't want the whole thing, right? I don't want this whole thing here. I just want this little piece of it here. Okay, so that shaded region, well, how do I know what that is? Again, it's just a fraction of it, and that fraction is going to be given here. It says 75 degrees, so that's saying the central angle is 75 degrees, and what that fraction is, 75 out of 360. Okay, so that's the fraction of times 25 pi. Okay, so I don't know if you're allowed to use a calculator with this or not, but this would be pretty easy to find. So this would be the sector area of a sector. And that's, again, something that you can put in your calculator. Okay. Okay, what was this one here? Sketch a circle with a central angle of 95 degrees. Mark the corresponding arc length, 20.9, and then find the circumference. Okay, so this is always what we're hunting for, is what is the actual thing that they're asking for. So they're asking for this, circumference. So I'm just going to put this over here. Circumference is 2 pi r. Okay, all right. So let's go ahead and first draw the central angle. Okay, 95 degrees, right? If it was this, right, if this was a right angle here, that's what it would be. But that'd be 90 degrees, but we're saying 95. So I'm going to make it a little bit more than that. So that would be my 95 degrees. Now we're going to label the arc length out here is 20.9 millimeters. Okay, so what is the entire circumference? Okay, well, here's the thing. This is a fraction of the circumference. So here's what I'm going to put. Here's the fraction, 95. So this is the fraction of the circumference equals 20.9. Okay, so the only thing we don't know is circumference. Again, this is more than anything, it's an algebra problem. So the circumference is 20.9 times, we would multiply by the reciprocal, right, to isolate the variable. And again, that's something you can go ahead and just plug into your calculator. Okay. So again, it's all about that idea of these sectors, central angles, all this sort of stuff has to do with it's just a part of the full circle. It's just a fraction. And the key understanding is right here, right? How to find that and using the central angle here to do that. Okay, let's see. I think we have another one of those. Oh, no, we go into polygons. Okay, yeah, okay, so all right, so now we're going to jump back up to here. Okay, so this is slightly different. And this particular problem here, it does require that you need to know a couple of things. One is the graphing form of a circle and what this equation here is, okay? This equation is for graphing. It just says that every single point on this circle satisfies this equation, okay? Now, this particular one, I need to know the h and the k. And what the h and the k is, that is the center. That is the location of the center of the circle on the coordinate plane. So the center is its x value and its y value. Okay. So what we need to do then to find out this equation of the circle is we need to convert this equation down here, which is considered in its general form, and we need to convert it to this. Now, this is not something that you can do in 2 minutes if you haven't learned how to do a couple of skills like what's called completing a square. So here's what I'm going to do. Okay, what we want to do is we want to make that perfect square trinomial in x's. So this is what we're going to do. So I'm going to take this 16 and move it to the other side. So I have a negative 16. Okay, now I'm going to group my x's together. Okay, I'm going to go x squared minus 6x, and then I'm just going to leave a blank right here. Okay, then plus, now I'm going to go ahead and group this, right? So I'm just rewriting this. Then I'm going to leave another blank here. Okay. So what I want to do, my whole objective is to take this and make it something that looks like this, some perfect square binomial. Same thing with this one here. In y, I want to get to this. Okay. So if you learned how to complete a square, I hope you've learned that in class, right? It would end up being x minus 3, right? You take that, you cut it in half, and then when we square that negative 3, we get a plus 9. And what I'm going to do, if I put a plus 9 on this side of the equation, I have to put it on this side. Now I'm going to go over here to this, that square here. Now this one I have to do, and this is going to be y, okay, cut it in half, 4, and then when we square it, plus 16. Okay, but I have to put that plus 16 over here. Okay, so what that does for me is, well, let me check the time here. Okay, right, tells me this is the graphing form. In other words, I can take this and replace it with this. So here's what I have: x minus 3 squared plus y plus 4 squared equals. And now when I combine all this, right, the 16s cancel each other out, and I have 9. And what 9 is 3 squared. Okay, so what that tells me is it asks for what's the center and radius of the circle. Well, the center is just like we talked about up here, that h and the k, h and k, right? So our h is 3. Our k is a negative 4. Notice the way that negative is here. Okay, so a negative 4, that's why that's a plus 4. So our center is at 3, negative 4. And 9, of course, is 3 squared, and our radius is equal to 3. Okay, so we're going to stop here real quick, and because I want to make these videos 2 separate ones. So we're going to